Now let's move over to what? Electrolysis, JAMB Physics class. Now, what I want to understand, here is that electrolysis physics and electronic chemistry, they are not the same. They're a little bit what difference. Just so in this video here, I will explain what is electrolysis, Faraday first law of electrolysis, the various formulas in solving problem under what Faraday first law of electrolysis. Then we have to look at, they want to solve some basic what calculation under what Faraday first law of electrolysis. Most of the questions we are going to solve in this class here are the main thing that JAMB normally ask, or any other exam if it's asked when it comes to electrolysis. Just so you want to stick to the end of this video here. Make sure you have your pen, your notebook, your calculator, so you can follow through this video here. If you have any question, only leave a comment section, and I'll be responding to what each of your question, right? So let's get into it. The first one to look at is what is electrolysis. Electrolysis is defined as the chemical change, the composition of compound in liquid due to the flow of currents. So the chemical change that occurs due to the flow of current in liquid is called what? Electrolysis. It's defined as chemical change in liquid due to what? To the flow of currents. Just like that is called electrolysis, right? Now, I will not be going details what is the electrolyte and the rest. I will not be going through those details now. So the next one I want to look at is called Faraday first law of electrolysis. Now, what is Faraday's first law of electrolysis? Please pay close attention here. Faraday first law of electrolysis states that the mass m of a substance liberated or deposited during electrolysis is directly proportional to the quantity of electricity Q passes through the electrolyte. Do you understand? So now when we talk about Faraday's first law of electrolysis here, it's very easy there. The quantity of mass deposited or liberated during electrolysis is directly proportional to the quantity of electricity that passes through the electrolyte. This is it here. Do you understand? So M is directly proportional to Q, right? Now this Q here is called quantity of charge, or quantity of electricity. Yes, this Q here is called quantity of electricity. Now, another thing I want to understand here is that we want to remove the proportionality sign here, right? If you remove the proportionality sign here, we're going to introduce a constant called Z. So it's going to be M equals to Z Q. Now, here is what is the mass, here what quantity of electricity, that passes through the electrolyte. Then here is what is called electrochemical equivalence. So Z equals to what? Electrochemical equivalence. The electrochemical equivalent here. Just now let's do a little calculation here. Let me show you what the unit, right? Now the unit of mass is what? So if you should make Z some formula, you're going to be Z equals what? M over what? Q, right? Now what is the unit of M? The unit of mass in physics is what? Is kg. What is the unit of what? Of Q is what? Is coulomb. The unit of Q is what? Is coulomb. Is what? Is coulomb here, right? So the unit of electrochemical equivalent is what? Kg per coulomb. Very important here. Another thing I want to understand here is that Q, the quantity of charge here, Q is equal to what? I what? T. Now I is what? Is the current. T is the time it takes, right? So this Q I think is called the current, which is the amperes, times time, which is what? Seconds here. So if you bring it down, let's do it here. So you're going to be, if you can also break it down, that my N is equals to what? ZQ, right? Now this Q is what? IT. So you can say M equals to Z I T. Can you see that? So this is one of the formula you make use of here. Mass equals what? Electrochemical equivalent times what? The current times time. Just now in physics they don't use the Faraday constant, which was 96,500. They didn't use it, but in chemistry they normally use it. Just and I will see how you can solve some basic problem under this place here. Now there's one thing to understand here. Right? There's one thing to understand. Please take this note down. Very important. Also, the mass of the substance deposited during electrolysis depends on the density of the substance, the area of the cathode, and the thickness of the substance deposited on the cathode. Just now. So when we talk about the mass of the what, the mass deposited, it depends on what, on the density of the substance. Number one. Now the area of the cathode. Number two, and the thickness of the substance. Just now. So please pay close attention here. So it means that, remember, what is density? Density, what is density is equal to what? Mass over what? Volume. Do you understand? Now, what we want to understand here is that the density of the substance is very important. D. Now, the area of the area of the cathode is very important, and the thickness, right? The thickness is very important here, right? Now, area is what? Is meter square. Thickness is meter. Just count. So my volume equals to what? Area. So the thickness, which is what? D. The thickness is denoted what? With D. So it's going to be what? Area times what? D here. Just count. So volume equals to area times the thickness, right? Now density, the symbol of density is what? Is P. Is what? Is P here. Just the symbol of density is what? Is P. The area, the symbol for area is what? Is A. While the symbol for thickness is what? Is D. So that means density equals to mass over what? Volume here, right? And volume equals to what? Area times the what? The thickness. Do you see that? So you can see that P, which one is density, equals to what? The mass over what? Area times the thickness, right? So if I should what? Make mass my subject of formula here, my mass is equal to what? The pressure, which is P, times the area, which is the area, times the thickness. This is that. Now the other thing to understand here, remember my M equals to ZIT, right? So here I can see that since my M here is also the same thing, the what? The density of the substance times area of the what? Of the cathode times thickness of the substance deposited too, right? So you are going to you can equate them together here. So here, let me just guys in here. So here we can now say what? P times area times the thickness equals to what? ZIT. So we can also use this one. We can also use this one in what? In what? Electrolysis, when it comes to what? Physics calculation. Just so you can use this one here, and you can also use this one here. So you have to see how to use the various formulas in what? Solve what? Questions under electrolysis in what? In physics, right? So please take this formula down. This first formula, this was second formula here. Then we have this one. Then we now have this one here, right? So you have 1, 2, 3, and what? And 4, right? So this is what the explanation of what? This is what Faraday first law. When the mass deposited equals to what? Is directly proportional to what? To the quantity of the electricity. Just so from here now we get the what? Electrochemical equivalent here. Electrochemical equivalent, which is Z, kg per coulomb. Just so you have this Q here equals to what? IT. I is what is current. T is what is the time taking, right? From then I get to this other point here. So these are things you need to pay close attention when you're solving questions under the first law of electrolysis. When it comes to what? The electrolysis under what? Physics, right? So let's solve some basic calculation. Now let's look at what? Two key questions under what? Faraday first law of electrolysis. Now the way JAMB set question, or the way questions on electrolysis set in physics is not the same with that of what? Of chemistry. So you need to what? Differentiate between two of them. Just so let's look at all these questions here. You not see this kind of question in what? In chemistry calculation. No, you can never see this kind of type of question. So let's look at the question together here. Copper of thickness D is plated on the cathode of a copper voltmeter. If the total surface area is 60 cm3 and a steady current of what? 5.0 amperes is maintained in the voltmeter for 1 hour, calculate the value of the D, right? Now they give us the density of copper here an electrochemical equivalent of of copper, right? So remember I told you that D, which is the density times area times the thickness equals to what? ZIT, right? This is the formula you are going to use here, right? Now, if you check it very well, they say calculate the value of the thickness, right? The value of the thickness here, which is D. If you want to make D the subject of formula here, you're able to get what? D equals to what? ZIT over what? P times what? A, right? So this is the formula you are going to use, right? My density, which is P here, is what? Is 8.9 exponential what? 3 kg per meter what cube, right? Now look at something here. The density is what is in meter, right? Density is what is in meter. But if you look at what the area is centimeter cube. So here is centimeter cube. Here is what is meter what cube. What does that tell you? You cannot use it like that. If you use it like that, if you use this thing like this in your calculation, you're going to fail it here. So you have to convert what this area to meter cube to meter square. Do you understand? So this area must be converted. This cm square must be converted to what? To meter what square. I'm going to teach you how to do that. Yeah, just pay close attention. But understand that here's what is meter, here is centimeter. So I have to convert what? Centimeter to meter. But they are all what in square. Do you understand? So here we have density here, right? Density of copper 8.9 exponential 3 kg meter per meter cube, right? But again, my current, which is the I, is what? Is 5 amperes. 5 amperes, right? Now the voltmeter maintained for 1 hour. So my time is what? 1 hour, right? Now hour must be converted to what? Seconds, because time is measured in what? Seconds. Do you see that? So going to be what? 1 times 60 times what? 60, right? $3,600, which is going to be 3,600 watts, 600 seconds, right? Understand this in here now, right? So we are looking for what? Our D. They give me what? Electrochemical equivalent here. Electrochemical equivalent here, which is what? LLC, electrochemical equivalent, which is what? 3.3 exponential what? Minus 7 kg per coulomb. Do you see that? So the thing is that my area is always my area. My area is what? Is 60 cm squared, right? So yeah, if you should like it, because we know all the values here, we know our P, right? We know our I, right? We know our T, right? We know our what? Our Z. This is the Z, electrochemical equivalent, which is what is Z here, right? Z. We know our Z, right? Which is this one here. Now, but the area is the problem. Do you understand? We must convert what? cm square to what? To meter square. This that. So how do you convert from cm square to what? Meter square here? How do you convert to meter what? Square. Now the reason why we must convert it here, because here is in meter. So cm and meter, they are not the same unit, right? So we have to convert it square and what? And square, because what is the area. Hope you understand. If you do like that, you're going to fail it. So now look at something here. You now say what is the relation between centimeter and meter, right? Remember, 1 meter equals to what? 100 what? Centimeter, right? 1 meter equals to what? 100 what? Centimeter. Hope you understand. But here is square. So if you square it here, put square here. Put square here. Just and please pay close attention here. Remember, in our conversion, the relationship between meter and centimeter is what? Is 1 meter equals to what? 100 what? Centimeter, right? Now, but this one is what? Is length. but they're talking about area, which is what square. So the only thing I want to do here is what the only thing I want to do here is what is to introduce what your square here. Introduce what your square here. Just that. So now it means that here we have 1 meter square equals to what 100 square is what is going to be 10 raised by 4, because 100 times 100 we're going to be what which is going to be what 10,000, right? Which is what 10 raised by 4 centimeter what square. This is that. What do you understand? So my area now, my area equals to what 60 centimeters square over 1 times. Yeah, the centimeter go to the down. Here we have 10 raised by 4 centimeters square. Here we have what 1 meter what square. Now the reason why I arrange like this so that centimeter square we can have centimeter square, right? What you have here is now going to be 60 what meter square over what 10 raised by 4. This is that. So I want to divide it here. Be what 0.006 meter what square. This is that. So it is the conversion that you need to pay close attention to. So from here to here, because here area is what is centimeter square, you are converting to meter square, right? What the relation between meter and centimeter is what 1 meter equals what 100 what centimeter. But here is square, so you have to square them here, right? So we're going to be 1 meter square equals what? If you choose square, so here we have 10 raised by 4. Do you understand? Centimeter what square. This is that. So which are going to play here. Here we have 0.006 meter what square. So this is now what my area here. So my area is now equals to 0.006 meter what square. This is that. That is it. So it's very important as a student, it's very important to know how to do this conversion here, because they are going to play a big part to your success or not, right? So we have formatted this one here. So this is what we have gotten here. So this is what you get, right? So what I want to do here is what input your values here. My D now is equals to what? Z. What is my Z? Z is this one here, right? 3.3 exponential what minus 7 times. My I is what? What is my I? My I is what? 5 times, right? What is my I? My I is what is 5 times my T. What is my T? 3,600, right? So this is what we have here over here my P, which is what my density here, 8.9 exponential what 3, right? Times my A. What is my A? My A is what 0.006. Is okay. So this is what you use here. So let's use our calculator to get our answer here. So you have 3.3 exponential minus 7 times 5 times 3,600 divided by, here we have 8.9 exponential what 3 times 0.006. So the answer here, my D is equals to what 1.11 times 10 raised to the minus 4, right? Now thickness is what is meter. Just and thickness is what is meter. So it now be what in meter. Just and so it's very important to know how to solve this kind of question here, because this type of question they normally what set under what electrolysis, Faraday first law of electricity, what in physics. Hope you understand this. So let's move to the second question here. So you can pause the video and go check watch the video again so you can understand what better. So let's look at question 2. Pay close attention here. Copper of mass 0.33 gram is liberated by passing coulomb 100 coulomb of electricity charge through a copper voltmeter. Calculate the mass of zinc deposited when a current of 2 amperes is passed through the voltmeter for 5 minutes. Please pay close attention here, right? So what they say should actually calculate here, calculate what the mass from here. If you check it very well, from here to here, this is what is the main question here, right? Calculate the mass of copper deposited when a current of 2 amperes is passed through the voltmeter for 5 minutes here. Remember, mass equals to what? ZIT, right? ZIT here. So from here now, if you check very well, now that's not to look for the mass, right? That's not to look for the mass. Now I know what my I. What is my I? My I here is what is 2 amperes, right? Now the time is what? The time T is equal to what? 5 minutes. Just of course you are converting what? Of course you are converting what? Minutes to what? To seconds by multiply by what? 60. So let it be what? 5 times what? 60. Do you see that? 5 times what? 60. Because why? The time is given in minutes here, but we cannot use minutes in calculation. You have to what? Convert to seconds. So to convert what minutes to seconds, you have to multiply by what? 60. Right? So it will be 5 times 60. Which is what? 300 what? Seconds. This is that 300 what? Seconds. So for us to be able to calculate our mass here, I need what? My Z. Right? So I'm not saying calculating what the electrochemical equivalent, calculating electrochemical equivalence. This is that. Calculating what the electrochemical equivalence. So how do you calculate the electrochemical equivalence here? Remember, we know that N is equal to ZQ, right? So if I know my M and my Q, I can really know what my Z, right? So if I should make Z so from my here, this implies that what? Z equals to what? M over what? Over Q. So it is this phase value here. Remember, my mass is what? My mass is what? 0.33 what? Gram, right? Then my coulomb Q here is what? What my coulomb? 100 what? Coulomb. Now remember, in physics, mass is measured in what? In kilogram, right? So you have to convert what? You have to convert what? Gram to kilogram. Right? If I convert gram to kilogram, you have to divide by what? 1000. You see that? So you must convert what? Gram to kilogram. If you don't convert to kilogram, that is the mass I'm going to get here. It's going to be what? In gram. Just and so you can, like, if you want to leave it in gram, fine. You leave it like this. But normally, the unit of mass in physics is kilogram. So let us convert this to what? To kilogram. 0.33 divided by what? 1000. Here we have what? Here we have 3.3 exponential what? Minus 4 kg. This is that. Hope you understand. So if you want to leave it in gram, that's my final mass here. It's going to be what? My final mass here is going to be what? In gram, right? But normally physics is measured in the unit of mass in physics is kilogram. So just let us convert to what? To kilogram here. Do you understand? So from here, you can really calculate what your electrochemical equivalent, which is what? Z here, right? So let me put it here. So it's going to be Z equals to what? My M. What is my M? My M is what? 3.3 exponential minus 4 kg over. Here we have what? 100 what? Coulomb. Yeah, remember here C coulomb. It's okay. So you have 3.3 exponential minus 4 divided by what? 100. Here we have what? So my Z here is equal to what? 3.3 exponential minus 6 kg per coulomb. This is that kg per coulomb. So my Z now, from this upper value given to me here, I've used to calculate my Z, right? Electrochemical what? Equivalent here. So here I can just say my Z is equals to what? 3.3 exponential minus 6 kg per coulomb. This is that. So with this place now, I can just wipe the whole of this place out, right? can wipe the whole of this place out. When I wipe the whole of this place out, what am I going to get here? I will now have what? M is equals to, here we have 3.3 exponential minus 6 times. My I is what? Is 2 times. My T is what? Is 300. This is that. So you have 3.3 exponential minus 6 times 2 times 300. You have what? 3.3 exponential minus 6 times 2 times 300. Here we have my mass here. M is going to be what? 1.98 exponential minus 3 what? kg. This is not what the final what answer. Hope you understand. This is not what the final what answer. As easy as that. So these two problems is enough for us to what solve under what electrolysis here. Although we are still going to do more questions under what Faraday's first law of electrolysis, but I don't want this video to be too lengthy. So, but with what I've solved here, you should be able to have an idea on how to tackle any question you see when it comes to what Faraday's first law of electrolysis, what in JAMB, what physics. Just all this video is helpful. Please, if you did video helpful, please leave a question on this video. This video is what is helpful, and I will be glad to hear from you. Kindly share this video with your friends so that they too can be part of the class. Thanks for watching. See you in my next video.